Hello students, welcome to this lecture in which we'll do a little bit of review of algebra for our decimation cipher to figure out what went wrong in the previous lecture. So we're going to start by talking about factors, and again this is mostly review, so that means you know this material and just trying to refresh it in your mind. So what is a factor? A factor of an integer n is a number a such that and some other number b exists, so that if we multiply a and b together, we're going to get the original number n back. So let's look at the example. In this example, we would like to find factors of number 6. For number 6, we have 1 because 1 times 6 is 6. We have 2 because 2 times 3 is 6. And since 3 times 2 is also 6, 3 is also in this list. And the number itself is also on the list. And always 1 and number itself are the factors. But then you have to see whether there are some other numbers that would be the factors. Then if we talked about factors, if we have a positive integer n for which only 1 and n itself are the factors and no other factors exist, this number is called a prime number. And there are a few prime numbers that we can just list. This question is still unknown what are the all primes, and it seems like there are infinite amount of them. So first few are 2, 3, 5, 7, 11, 13, 17, and so on, just few examples of primes. Composite number is a number that is not prime. So if number is not prime, it's called composite. So that means there are more than 2 factors. And one note over here that we would like to make is that number 1 is neither prime nor composite. Neither prime nor composite. It's an exclusion. So let's look at a few examples. If we look at number 24, it has a lot of different factors. I hope I list all of them, 2, 3, 4, 6, 12, and obviously 1 and 24 itself are always the factors. So this number would be a composite number. And the number 19 on the bottom is prime, since only factors are 1 and 19. So relatively simple idea. Then another thing that we would need in these calculations is greatest common divisor. And greatest common divisor of 2 numbers, a and b, and usually people write GCD, greatest common divisor a comma b, is the largest integer that is a factor for both a and b. So let's look at the greatest common divisor of 6 and 8. For this, we write all of the factors of 6 that we did before, 1, 2, 3, and 6. Then we list all factors of 8, 1, 2, 4, and 8. And we see that 2 is the biggest number that is present in both lists. So 2 would be the greatest common divisor of 6 and 8. Next idea is probably you haven't seen it before. It's called relatively prime numbers. So 2 integers a and b are relatively prime if greatest common divisor of both a and b is 1. This means that 1 is the only factor that is common to both list of factors of a and b. So let's think if a and 9 are relatively prime. If you look at 8 itself is not prime number, and 9 itself is not prime because 8 is 2 times 4 and 9 is 3 times 3. So what would be the factors of 8? The factors of 8 are 1, 2, 4, and 8. The factors of 9 are 1, 3, and 9. So we see that the greatest common divisor is 1 because that's the only one that is shared by both. So we see that greatest common divisor is 1, and so 8 and 9 are relatively prime. So each one of them is not prime, but comparing to each other, they are relatively prime. All right. So now we're getting closer and closer to our idea that we're going to need for our calculations. So if we take a number which is a mod n with greatest common divisor of a and n to be equal to 1, so basically this tells you that a and n, a and n are relatively prime. Relatively prime. So if they're relatively prime, then they call the unit. This number over here is called the unit. Unfortunately, if a is bigger or equal than n, then we need to use modulo operations to simplify the expression before we decide whether it is a unit or not. So what do I mean by this? Let's look at a few examples. In the first example, we have number a to be 12, we have n to be 19. The question is 12 mod 19 a unit? To answer this question, we have to calculate greatest common divisor of 12 and 19. And we can see that since 19 is prime, there are no other factors besides 1 and 19. So 1 would be the greatest common divisor. So that means that 12 and 19 are relatively prime. And we can conclude that this quantity over here is a unit. So that's our conclusion, because 12 and 19 are relatively prime. Let's look at the next example. In this example, we have 23 and 20. The question is 23 mod 19 a unit? Misprint here, sorry, should be 20 here, should be 20. Didn't type it correctly. So 23 mod 20 is a unit, right? So since 23 is bigger than 20, we have to simplify first. What do we mean by simplify? We mean we have to do the modulo calculation. So we're going to take 23, and we know that 20 goes in 23 once. So we subtract 23 and 20. We subtract 23 and 20, we get 3, and so 3 goes over here. So it's 3 mod 20. But now we see that 3 is less than 20, so we can redo the things that we did in the previous example. So we see that since 3 is prime number, then the greatest common divisor would be 1, because there are no other factors on 3 besides 1 and 3. And 3 definitely does not divide 20. So that means that 3 and 20 are relatively prime. And then since they're relatively prime, we make a conclusion that 23 mod 29 is a unit. The next idea is opposite of the unit. So we call something a zero divisor. We call something a zero divisor. Is number such that there exists some other non-zero integer b, such that if we do the modulo calculation n, a times b mod n will be equal to 0. A times b mod n will be equal to 0. We also have to notice if a times b mod n is 0, and since mathematical operation of multiplication is symmetric, that means a times b is the same as b times a, then a and b are both zero divisors. Not only a is a zero divisor, but b is also a zero divisor, because for b we have number a such that b times a modulo n is equal to 0, right? Which you can just write them in opposite order. But what we can do, we can just switch them around and it will work too. So let's look at the example. We ask if a equals to 13 is zero divisor mod 26, and explain why it happens, right? So let's create a number b equals to 2. Then take 2 and 13 and multiply it. So if we take 2 and 13 and multiply it, we're going to get 26. And 26 is evenly divisible by 26. So we get 0 as our answer, and the conclusion is that 13 mod 26 is a zero divisor. Are there any other numbers than 2? Definitely 4 would work, right? A lot of numbers would work. So these are zero divisors. So can we connect units and zero divisors together in one rule? Actually, theorem 9 on this page will do that. So if we take a number a mod n, it could be either a unit or a zero divisor, but not both. So it's either one of them, but not both. That's it. This is really a powerful theorem. It tells you if you calculate any number a mod n, it's going to be either a unit or it's a zero divisor, and that's it. So how do we perform a check? To perform a check, we just need to calculate one thing. We just have to calculate GCD of a and n. That's it. So if GCD of a and I said b, but that's a mistake. Should be n and should be n. Sorry. If GCD of a and n is equal to 1, then a mod n is a unit. But if GCD of a and n is not equal to 1, then a mod n is a zero divisor. That's it. So the only thing we need to calculate is GCD. That's the beauty of this calculation. So let's use this theorem 9 to tell us what are the units and zero divisors by using GCD. So if we take x mod 12, where x is between 1 and 12, what happens if x is 13? Why do I only take numbers between 1 and through 12? If x is equal to 13, then we can do modular simplification. That's the beauty of modular calculation, that you don't need all of the numbers, you only need numbers between 1 and 12. So what is 13 mod 12? Since 13 is bigger than 12, we can take a difference between 13 and 12, so we're going to get mod 1 mod 12, but 1 is in this list. So any number bigger than 12, sorry, will wrap up and will go below, and it will be between 1 and 12, right? All right, maybe I should change it and put it 0 to 11. Probably 0 to 11 is even better. All right, so so let's do this example. So what do? We just calculate GCD of 1 and 12, and GCD of 1 and 12 is 1, so that means it's a unit. It's a unit. GCD of 2 and 12 is 2, so it's a zero divisor. Greatest common divisor of 3 and 12 is 3, so it's a zero divisor. The same is true for 4. It's going to be a zero divisor. And 5 and 12, greatest common divisor is 1, because 5 is a prime number. And 5 does not divide 12, unlike 3. 3 divides 12, that's why it's a zero divisor. But for 5, we're going to get a unit. And we can keep going. I stopped here, but we can actually list all units and zero divisors. We can do that. And that's the end of this small review. And after this review, we're going to go back to the decimation cipher and fix it. See you in the next lecture.